I wanted to discuss an important feature of RC and RL circuits, and that has to do with the properties of the capacitor and the inductor with a sudden change, like switch action. So this is really important. A capacitor cannot change voltage instantaneously. So you might think, if you had a circuit like the one I'm about to draw right here, with a switch, that as soon as I close the switch, the capacitor would have whatever voltage that it had, or alternatively, if what I just drew is the after picture, so if before time t equals 0, I have the switch and it's closed, and then at t equals 0 it opens. You might think that the capacitor would have whatever capacitance, whatever voltage it would have as soon as the switch changes, but it doesn't. It cannot change its voltage instantaneously. It takes a matter of time. So let's look at an example here. Let's say that this is 10 volts, and let's make this resistor 2 ohms. And how about we make the capacitor 0.1 farads? These should be numbers that are not too bad for me to deal with. I will probably still make mistakes since I'm making up the problem on the spot. Okay, so my question is going to be, at time t equals 0, so at time t equals 0, what is IC of t and V naught of t? Okay, and those are just defined with the current in a certain direction and the voltage with a certain polarity. And what are those at time t equals 0? So time t equals 0 is a single point in time, but not everything has to be continuous at that single point in time. So if I am talking about a capacitor, I can have a function that at time t equals 0 goes from having no current to having some kind of current. But my voltage can't do the same. So whatever my voltage is before, that has to be what it is at t equals 0, and then it can start changing. So in this particular example, let's go back up and look at our circuit. So in this picture on the left, assume that the switch has been closed for a long time. A long time meaning at least 5, 6, 7 time constants, and that should be enough for the capacitor to get fully charged. So what happens is, under DC conditions, after the capacitor has been there long enough, it will become fully charged, and it will have some voltage associated with it. And whatever voltage it has, that it'll have the same voltage as the things that it's in parallel with. And so if we look at our picture here, our capacitor is in parallel with both our voltage source and our resistor. The voltage source is the easiest one to use, so because it's in parallel with the 10-volt voltage source, so VC of 0 has to equal 10. Now, that's actually VC of 0 minus, because this is before, so this is when the switch has been closed. So assume switch has been closed for a long time, and so when the switch has been closed, VC is going to be 10. What about IC of 0 minus? Well, if it's been closed for a long time, it's fully charged, and a charged capacitor does not conduct current. It acts like an open circuit. So a charged capacitor will have zero current flowing through it. Okay, but that's just 0 minus. Let's take a look at 0 plus. So 0 plus we open up the switch, which makes it so that this left part of the circuit is not connected to the right part, and so this voltage source no longer does anything. So right at switch action, what happens is the circuit becomes like this. Now, our capacitor was charged up to 10 volts. So I will say that's V initial for the capacitor is 10 volts. And so when you first open up the switch, the capacitor is going to act like a little battery, and it's going to send a current out in this direction and collect the current here, and that's what it'll do. Okay, well now let's find out what IC of 0 is. So IC of 0 is the current through the capacitor. And what do we have? 0.1 farads, 2 ohms. Now I know the current is going in that direction because the positive side of the capacitor is on the top, and so the current will flow from the higher potential to the lower potential, so it can go from the top down to the bottom. And we defined IC of t as going down, and so our answer is going to end up being negative because it's not going down, it's going up, so it'll be going in the opposite direction. And to figure out our current, this is only our instantaneous current at time t equals 0. So at t equals 0, V of t equals 10, because it was the same as that voltage source. And then we know that V equals IR, or 10 equals I times 2, and I equals 5 amps. So I is 5 amps, but notice that our 5 amps is going in this direction from the bottom to the top on the right hand side, and IC of t is defined as going down. And so we're going to say that IC of 0 plus equals 5 amps. Well, negative 5 amps, because it's going in the opposite direction from how it's labeled. So it's labeled in the picture as going up, but it actually is going down, so we'll call it negative 5 amps. So now we can put it all together. So VC of 0 minus equals VC of 0 plus equals VC of 0, as it always does, and in this case that would be 10 volts. Now IC of 0 minus equals 0, because at 0 minus there is no current flowing through that capacitor, because it's 0 minus, is acting as a short circuit. But that is not the case at IC of 0 plus. At IC of 0 plus, it is acting as a voltage source, and our current flowing through it is negative 5 amps. Now, what about an inductor, you may ask? Well, I'll make another video for that. But I also just realized you might be curious about what happens at infinity. So at infinity, you want to realize that once again, it has been in some situation for a long time. So if our voltage source is constant, which in this case it is, we should end up with and we don't have other elements, we should end up with a constant voltage across our capacitor at time t equals infinity. So let's think about our system here. And when we closed the switch, this right-hand part of the circuit became isolated, and our capacitor began to act as a little battery. And so current began to flow. And so the energy that was stored in this capacitor is being discharged, and as it does, the energy is getting dissipated through the resistor, and it is being lost in the form of heat. And so, given enough time, all of the energy stored in the capacitor will dissipate. And so, by given enough time, the capacitor will have 0 voltage left. Regardless of the resistors that is going to happen. So as t goes to infinity, the Vc of t goes to 0, and because the voltage is going to 0, the current is also going to 0. So we can add to our little collection over here that Vc at infinity equals 0 and Ic at infinity equals 0. Now that's not always going to be the case. It is here because there is no power source in our circuit once we close the switch.